to say about sound of interference experiment. Oh, it sounds interesting. Let's do our experiment. Seriously? Okay.
This is how constructive interference occurs. Constructive interference is when two speakers are producing the same tone, it will produce same wavelength. The two waves travel the same distance, therefore they arrive in same phase. For the constructive occur at the other point, the upper wave has to travel further than lower wave, therefore the wave arrive in phase. The loud sound occur and also known as antinote. So let's take a look what I have been explained just now. Okay, next is how destructive interference occur. And next is destructive interference occur when the crest of one wave meets the throat of another, and the result is a lower total amplitude. When the upper wave travels one half of a wavelength further than the lower wave, the throat of the bottom wave overlaps the crest of the upper wave. Then, destructive interference occurs and known as note.
This is microphone. It used to detect the sound of speaker. This is speaker. It is used to produce sound. This is function generator. In our experiment, we use it to generate sound with frequency which is 3400 Hz. This is stepper motor. We use the stepper motor to move the microphone to get the sound at every point that we decide.
Function generator produce frequency which is 30,400 Hz, and the microphone will receive the signal from the speaker and generate it to Audacity software. The stepper motor will move at every 1 cm until 30 cm to the right and to the left. From Audacity software, we will select certain wavelength to analyze by using plot spectrum to get high intensity of sound.
This is our result for Audacity that we interpret from Audacity to Notepad++. Okay, when we compile all results from 10 cm until 60 cm for y-axis and we plot using GNU plot, we will get this graph. Okay, this is result when we plot using GNU plot. This is for z-axis and we move the stepper motor to the left and to the right 30 cm. Okay, this is for y-axis. We change the y-axis from 10 cm until 60 cm. For z-axis is for intensity of sound. From this graph we can see this is for destructive and constructive. This is destructive and constructive. Okay, we can see the graph from any angle. This is from z-axis, this is from y-axis, and this is from the top. Since we are conducting this experiment, there are some errors occur which are when we try to get the sound of frequency in the laboratory, another voice or noise also detected by the Audacity software. Therefore, we get combination of sound for our experiment so that the data is disturbed by the noise of environment and people. Next, let me show you another error. Here is the draw of the wavelength. As you can see, this wavelength has so many points. But in our experiment, we just only take the points at certain place, which is, we just take this point, and only this point, which is, when we get the graph is, it just has a straight line. Should be, the experiment have so many points. This is due to our distance of x, which is so small value.